So it says the three graphs labeled 1, 2, and 3 are shown above. One is the graph of f, one is the graph of f prime, and one is the graph of f double prime. Which of the following correctly identifies each of the three graphs? So without just giving you the answer, because that'll make you force you to focus your attention on just that one, I want you to think about approaching this as if you were to look at it on an exam and how to go about possibly eliminating certain choices. So you may not know where to start. So let's say, okay, I feel lost. So I'm gonna start here. If I let this be f, could I possibly have an f prime either 2 or 3 be f prime? Okay. If this is f, if 1 is f, I look at this and I think, okay, the tangent lines would have a slope that is negative for a while until I get to about 1.5 or 1 3/4. Then the tangent line would be 0. So do I have these other two graphs, 2 and 3, do they show negative values of their functions from 0 till about 1.5 or 1 3/4? 2 starts off positive, so okay, that could not be f prime if this is f. And 3 starts off going positive values. So therefore, I know, the way I did this is, okay, I thought, I know that 1 cannot be f. So choice cannot be f. Because there's neither one of those could be f prime. Alright, so that eliminates choice A. Okay? Look at my 3 remaining choices, and I hate to do it this way, but this is the test-taking strategy, kind of thinking that typically, especially if you eliminated one of the choices, you have a couple of choices where they both contain choice 2 for f. I'm probably going to go ahead and maybe say this in this one, but I'm not going to eliminate D, but I'm just thinking that in my head. Okay, typically that's the way it is. Usually, rarely is it something like this, but that's not the way we necessarily want to think about it. Let's actually think about doing the problem. This can't be f. Could this be f? Well, let's see. If this is f, could either one of these be f prime? So this starts off with tangent lines that have a slope of, well, the first one would have a slope of what? The first tangent line at x equals 0 would be horizontal, wouldn't it? If 2 were f. Right, you guys see that right there? This guy yes?
I have a question.
Yes.
Since we just found out that I doesn't, like, none of those can be the derivative of I, don't we automatically know I is last? Because none of them are the derivative of it? Well, I can still be the derivative. Yeah, but it can't have a derivative, so it can't be last.
That intuition.
Yeah.
Wow, very nice.
So then we automatically know it's C.
Right? Because this has no derivative. So even if one were f prime, well, that couldn't be possible because it would need its derivative, which we've shown that. Aha. So we're automatically done. Very good. Done. That makes sense. Anyone not understand what she said? Okay, so what she said was, what Kate said brilliantly was this. Because there's no, if we look at Roman numeral 1, neither 2 nor 3 could be derivatives of Roman numeral choice 1. Therefore, not only can it not be f, but it couldn't be f prime because neither one of these would be f triple prime. So you got to really look at these individually, like, okay, this is this and this is this. And you would be done like that. You'd be done. It would have to be f triple prime. Okay? I'm going to talk about it more because I want to give you guys the most information that you deserve to have, because when you look at this, you may not have that intuition that she had. Think of it like that and immediately be done with it, which is great if you can. But let's continue. Let's say you went down this path and you didn't see that, but you go, okay, I've eliminated this choice, and I know I'm down to these choices. And say, okay, if I look at this, if this were f, notice its first tangent line is horizontal and would have a slope of 0, and there's only one choice that would work. So if this were f, this would have to be f prime. I don't know why it's control prime. If this were f, this would have to be f prime. And if this were f prime, the only remaining thing left, this would have to be f double prime. If it is this the derivative of this? Let's see. Tangent line. So it's going to be positive, positive, positive. It's going to be 0. Its derivative is going to have a value of 0 at halfway between 0 and 1. Okay, that occurs. Well, let's just go with what we know is easy. We know that's also going to be 0 at 3. That also occurs. Let's see. Negative from here to here, it is negative. And then the tangent lines all have a slope that are positive from 3 moving forward, which also occurs here. So f prime, f double prime, which is choice C. F, choice 3 being f prime, and choice 1 being f double prime. So I think the biggest key, one of the starting element of this is understanding derivatives as the slopes of the tangent line at any point. But again, what Kate said was that because if we let this be f, neither one of these were derivatives of this, therefore this would have to be the last guy. This would have to be the lowest, the f double prime would have to be. Because even if it were f prime, well, then one of these has to be f double prime, and that's not the case, because we just showed that if this is some function, neither one of these is the derivative of it. So it would have to be the last of the list. It would have to be the f double prime. And they go more into this in the text later on. But I wanted to look at this because I think it's a good problem. I think you guys can grasp it right now, because we haven't. It's not a problem that involves fundamental theorem of calculus, first or second part, or anything that we haven't learned yet. Any questions about this problem? Okay.
Okay, wait.
Yeah.
So how, explain to me in human terms.
Okay.
How 2 and 3 make up the derivative.
Okay, so how is 3 the derivative of 2?
Just because of the horizontal there?
Not just because of that. I have to look at the whole picture. So if I look at 2, I think, okay, the derivative is the slope of all the tangent lines. So let's start off. What would be like the tangent line when x is 0? It'd be a horizontal line, right? Mm-hmm. So this guy, if it is the derivative of it, it better be 0. The value of it better be 0 when x is 0, and it is.
Oh.
And I say, well, let me keep going. So it also better be 0 when x is 1, 2, 3, 4, about 4 and change, about 4 3/4 or so, just before 5. 1, 2, 3, 4, and it actually does cross at the x-axis at that point. All right, so were there any homework questions? I would have thought I would have definitely gotten questions for 11 through 18. Page 194, number 1 through 29, odd was adjusted work. Or maybe even 119 through 30.
Do we work on 15?
Sure.
Oh, sorry. Oh, I didn't click what you. Yep, brain wasn't functioning. That's why I said no. I didn't really want to click. I was shook my head no.
From the interval 0 to 7 pi over 4. Okay, so the directions are to use analytic methods to find the extreme values of the function on the interval and where they occur. So let's review. To find the extreme values, we need to cover the critical points, which is where f prime equals 0, where f prime doesn't exist, and the endpoints. So those are the three things we need to check. So I'll go ahead and I'll write that. What's that right over here? And the endpoints. And once we check all three of these things, we just compare them, see which has the greatest value, the least value, and then we can claim, okay, this is the absolute max, the absolute min. And we call the other one the local, wherever it's left. And there may be more than three values. What if there's more than one value where f prime of x equals 0? Okay, so we have to list all of them. It may not just be three. There may be a few of these that fit this criteria. There may be a couple points that fit this criteria, use only one, but maybe one or two, and endpoints. Now, in fact, I probably have a feeling there's going to be more than just three because knowing that how sine works, how it oscillates the wave. Okay, so let's find f prime of x. We definitely need to get started with that. So f prime of x would be equal to the derivative of sine of whatever is the cosine of, leave this alone, times the derivative of the inside, which is going to be what?
1.
Just 1. Good. Pi over 4. Pi over 4 is just a constant. Derivative of x with respect to x is 1. So I'm going to go ahead and erase that. Now you know what? I'll leave it there, and I'll just on the next line down, just to show that it was taken into account. Okay. So without letting this get confusing and thinking about, oh, the shifting, the horizontal translation and all that, let's think about what you know about the basic cosine function, right? The basic cosine function says, I'm going to have to shrink this down. Let's do this. Okay. Basic cosine looks like, let me get this glare off. Cosine, this is where it helps to have a basic understanding of these. And so if this is new to you or you didn't study this in AP Calc, so this may be the first time looking at these, but you should know. So cosine starts at 1, goes down, comes back up, and then it just repeats forever and ever. So cosine of x is going to be equal to 0 at, if this is a full period of 2 pi, then here we have at pi radians, and then here we have pi over 2 radians, and here we have 3 pi over 2 radians. Is this new for any of you all? Okay, just kind of a refresher. Okay. So this is the graph of just cosine. Okay. So we'll say that this is theta, and this is cosine of theta. Okay, I'm not doing this one specifically. What I'm going to do is I'm going to let this be theta and go from there. So where does f prime of x equal 0? Well, f prime of x, which is this. Well, when this is pi over 2, 3 pi over 2, and we got to make sure that we keep going far enough to cover all the way to 7 pi over 4. Now 7 pi over 4, think about comparing that to this is what, 6 pi over 4? We put it in terms of fourths. So 6 pi over 4 is just before 7 pi over 4. And even at 2 pi, which is 8 pi over 4, we're not going to hit 0 again. So these are the two values we're concerned about. But if this were significantly larger, you have to consider the other ones. Okay. How could you figure that out, by the way, if this were not just something as small as this? What you could do is you could say, okay, if theta is pi over 2, that's when that function is equal to 0. And this has a period of 2 pi. I know that at pi over 2 plus 2 pi, this is also going to equal 0, plus another 2 pi is also going to equal 0. So this plus 2 pi, pi over 2 plus 4 pi, pi over 2 plus 6 pi, to handle all the iterations, all the repeats.
Because it's x plus pi over 4, doesn't that shift the graph?
It does. So this is what I'm going to do. So I don't like that. So what I'm going to do is I'm going to let this be theta.
So it's going to be like that. Pi over 2.
Well, because I know, for example, that the cosine of pi over 2 equals 0. So I'm going to let this be pi over 2 and see what x would satisfy that. Right?
I mean, that works. I just would never think to do that.
Do whatever. If you're comfortable with, you want to do like graph just this, go ahead and graph
no,
that.
I was saying I don't remember how the x shifts it. So.
Oh yeah, so like this, yeah. So the whole.
I don't want to have to worry about
neither do I. I personally don't like dealing with all the transformations. To me, was like the most boring, one of the most boring topics ever. Oh, this goes up and it gets stretched and it gets. If it's your thing, great. But I didn't personally care for it. But what would happen was it would be a horizontal translation to the left pi over 4 units. And that to me is just more of a pain to even graph than it is just to graph this and then let theta be this. Yes?
So, you would have pi over 2.
Yeah, I'm going to let, exactly. I'm going to let this be x plus pi over 4. Because I know that the cosine of pi over 2 equals 0. So I'm going to let this be pi over 2 to find what value of x satisfies that. The only thing is here, though, is when this occurs, make sure that you're not missing one. Okay, this is going to shift it, what, to the left? So make sure it shifted enough to the left that you're not missing one. So what you can do to be safe is maybe list like another one. It would also be 0 at 3 pi over 2, 2 pi, and then back down to 0 at another, what, another half pi. So 2.5 pi, which is what, 5 pi. Right, and then if it's too far over, I'll just eliminate it as a possibility. Okay. So from here, let me move this over. Let me move this out. I can't just select that. Really? Alright, I want to erase it though. Let's see. I want it all to be kind of on the same thing here. I'm going to write, I guess I could probably write small here. So let's do this. I could say that x plus pi over 4 could equal pi over 2. I could write x plus pi over 4 could equal 3 pi over 2. And I could write that x plus pi over 4 could equal 5 pi over 2. Does anyone have any questions as to why I'm doing this?
Could do any one of them and get the answer, but you don't have to do all of them, right?
Yeah, I'm going to do enough so that like when I solve for x, as long as it falls within that interval, because that's the only interval we're concerned about. Right? I'm not going to consider x that are past 7 pi over 4.
Yeah, but do you have to solve each one that is in the interval?
Well, yeah, I got to find x.
Okay.
Yeah, I got to find x. But is anyone concerned like why I'm doing this? Okay, so here we go. So then x could equal, so fractions, right? Pi over 2 minus pi over 4, which is 2 pi over 4 minus pi over 4, which is just pi over 4. Here, x would equal 3 pi over 2 minus pi over 4, which is 6 pi over 4 minus pi over 4, which is 5 pi over 4. And then this one here, x would equal 5 pi over 2 minus pi over 4, which is 10 pi over 4 minus pi over 4, which is 9 pi over 4, which I don't care about this one because it's outside the interval. The only other one to consider that maybe I didn't consider because this shifts to the left would be on the left side of it. Yeah, negative pi over 2, but I don't think it's going to work. So if I tried that, if I said x plus pi over 4 is equal to, right, negative pi over 2. So x is equal to, if I were to subtract pi over 4, it would just be even more negative. So it's not going to work, but it would be what? Negative 3 pi over 4. Right? So just make sure you list enough and say, okay, the ones that are outside the interval, the ones that I don't care about are this one, that's outside the interval, and this one. So I know I covered all the ones that are inside the interval, right? So here are two values of x that make f prime of x equal to 0. So we've taken care of number 1.
Do you have to find the large one?
Eventually, yeah. Because you're going to be talking about the relative extrema. So yeah. So this is part of number 1. So I'm going to go ahead and label. This was from number 1, this one, and that one. So now number 2. Where does the f prime not exist? Well, this is just a cosine. This is just a wave. There's no issue. Yeah, there's no issues of just basic intuition of being a wave. There's no issue of a vertical asymptote or a hole or anything like that. So 2 is taken care of. So it gets a check mark. I said, and I could say here for so because cosine of x plus pi over 4 is, you could say what, continuous. Okay, and then that last one, the endpoint, which is easy enough. Plug in. Now be careful. You know, the endpoint of the function. So you're plugging in 0 into the to the function sine of x plus pi over 4. You're plugging in 7 pi over 4 into f of x. So number 3. F of 0 would be equal to what? You have sine of pi over 4. This is where it helps to know, again, the basic, whether you memorize a 45-45 triangle, a 30-60 triangle, or if you know it by the graph of it. Like say it's a problem in a part of the test, and you didn't have a graphing calculator. This is why it's important to have that intuition. So so what is the sine of 45, or pi over 4 radians? What's that? Root 2 over 2, yeah. So 45, think about opposite of pi is 1 over root 2, or root 2 over 2, good. So f of 0 is root 2 over 2. Does anyone want to see that triangle that I'm talking about? You guys got it?
No, can I see it?
Yeah. So the triangle is, if you have a 45-45, or knowing that pi over 4 is 45, 1 root 2. So when you do opposite over adjacent, 1 over root 2, if you rationalize, you get square root 2 over 2. And then f of the other endpoint, 7 pi over 4, is equal to what? So if you plug in 7 pi over 4, 7 pi over 4 plus pi over 4 is 8 pi over 4. which is 2 pi, which is the same as finding the sine of 0, which is 0. Right? Now you think about a sine function. It's the one that starts at 0 and goes up. Sorry if this is written in on the black. Any questions thus far? How we came up with all these?
So which ones of all of those are really critical?
And that.
Like I always know how to get here, but like.
Oh yeah.
How
So
are these
the critical points are 1 and 2.
Yeah.
Critical points are 1 and 2. Yeah. Critical points where f prime equals 0 or f prime doesn't exist. So then now you just compare all of these. So we're going to compare the point 0, square root 2 over 2, 7 pi over 4, 0. Obviously this one is larger than this one, but we want to find both, all the local extrema and then label, okay, this one's the absolute max, this one's the absolute min. So if we do that, you have to go through the, I wish I could fit it all in one, but it looks like that's not going to happen. But what you would do is you'd say, okay, plug pi over 4 into here, find out whatever that is. Yeah, find the value of it. Yeah, this one and this, well, only these two. These are only two that were within the interval. Yeah, for x. Yes?
If you happen to know the sine and cosine for final equations or like actual
Mm-hmm. Yeah, so you have to plug pi over 4 into here. So you have to find the sine of 2 pi over 4, or 1/2 pi, which is 1. Does anyone, you guys want to see that on here, actually working it out all the way to the end? Okay, so let's do that. So let's do that. I'm gonna erase this triangle. I think as a quick review. Yeah, is that okay? Just because I want to fit us all on one page. What's that? I think I'll draw some arrows. So f of, I'll label maybe 1 or something. So f of pi over 4 equals the sine of 2 pi over 4, or 1/2 pi, which is 1, because it goes 1/2 pi is at 1, 0 at next one, all the way, okay? And then the other one is f of 5 pi over 4, which would be equal to the sine of 6 pi over 4. Which is the same thing as 3 pi over 2, or 1/2 pi. So 1/2, 1, 1/2, negative 1. I am going to continue this on the next slide because I'm going to write all of those. So, our local extrema. We list them all out. And like I said, I would label this. So it's
going to be absolute.
Two of them are going to be absolutes. We're going to list all of them.
Okay.
This one here, and this one here. That's from here, here. Okay, so they all are, we have pi over 4, 1. We have 5 pi over 4, negative 1. And then we have the endpoints 0, square root 2 of 2. finally the last guy, we have 7 pi over 4, 0. So here's our local extrema, and we really just want to be concerned about, I guess, labeling the absolutes. Let's see, they said maximum value, minimum value, and then they talk about a local min and a local max. But the maximum value, the absolute max, would occur at, this is a little bit more than 1/2, but not quite 1, so this is the absolute max. And then of all these, of course, this one's the absolute min. Yep.
And we're comparing the y values.
Yeah, exactly. Because the y by that is the actual value of the function. Yeah. You guys good? Okay. Which one? $27. $21 says we have 27.
Yeah.
All right. So 27 says we have y is equal to the square root of 3 plus 2x minus x squared. Okay. The way I think about this, in order to figure out the derivative, is I think about 3 plus 2x minus x squared to the 1/2 power. So y prime using chain rule, 1/2 to the front, leave the guts alone. Drop this down power, negative 1/2 times the derivative of the inside, which is negative 2x plus 2. So this is y prime. And again, checking where f prime equals 0, where f prime doesn't exist, and the endpoints. And is there an interval specified for this one? There is not. Okay. So what does this graph look like? What does the end behavior look like? Because if it goes like this, there is going to be no absolute max or min. Or if it goes like this, there's going to be no absolute max or min. Correct? Mm-hmm. Yeah? How do I know the graph looks like? That's good. So I'm going to know what point do I assume if you're not going to have a graphing calculator? So if you do not have a graphing calculator, if you look at this and you were to say the big picture is you have, looks like it's going to be something that looks possibly linear. I don't think there's going to be any vertical, there's going to be no vertical asymptotes. That helps with starting off an image of this, right, for y. There's no vertical asymptotes. And we can't have the square root of a negative. Can you go like that? Let's look it up.
It does.
Did you graph it?
We had to memorize it last week. Yeah.
Oh, for everyone, let's go ahead and have a look.
Yeah. I remember like the main. Why were the radius of the Earth?
For advanced topics.